Welcome to Ask and Learn.
In this problem, we are talking about a direct application of integration, and that is finding the volume under a curve. So how do we do this? There are two methods. There's a cylindrical shell method and a washer method. We are going to be using the washer method. And so this will make more sense when we talk about the function we're given. So this is our coordinate plane, and this blue line is our function. These dotted lines are the interval that we are investigating, and this red line is essentially the height of our function. So now what we do is we essentially rotate this or reflect it across the x-axis. So you can imagine we have this really long line here, and we essentially call that a disk, a washer, and we essentially add up all of these washers together to find the volume that would be created by our function. So you can see that this is a direct application of integration. We are finding essentially a sum of all of these washers, which is what an integral will do. So now let's find the volume for the function we're given. So the volume is going to be equal to pi times the integral from 1 to 4 of our radius times dx. The radius, again, is this red line. Imagine that this would be a full circle. This would be the radius. So now we can plug in some information. Our volume would be equal to pi times the integral from 1 to 4 of 1 over x squared in dx. And then we can antiderive this. Our volume would be equal to pi times negative 1 over x evaluated from 1 to 4. So our volume is pi times negative 1 over 4 plus 1 over 1, and we can simplify that to 3 pi over 4. So what we just found is that using the washer method and the function we're given, the volume that would be created by that washer is 3 pi over 4. So I hope this problem helped you understand a little bit more about how we can use the integral to find the volume under our function, and then specifically how we go about one of these problems using integration and a given function.